My name is Anwar Gonzalez. I'm an aspiring astrophysicist. I'm currently studying at Southwest Texas Junior College. This is going to be my mock TED Talk presentation for Composition 2 for Mr. Johnson, and I invite you to embark on this journey in our mystifying universe. And without further ado, the universe, a fascinating entity that is responsible for the creation of everything everywhere. The only thing more fortuitous than the inception of the universe is the origination of the human species, if not the privilege to be able to sit and autonomously ponder about your conception out of cosmic and terrestrial reality. Since the beginning of human civilizations, humans have by nature explored, pursued, and invented by all aspects of the terms. Until we didn't. Granted, humans, their renovations, as well as their advancements and establishments in education is an admirable feat. It remains minuscule to what is theoretically capable at the cosmic reality. However, for scientists to continue to make groundbreaking discoveries, especially in astronomical territory, they must first understand what they are truly working with, which remains to be the issue. Currently, astronomers are not able to detect or even comprehend about 96% of what the universe is composed of. The latter 4% is what we and everything around us is made up out of, such as oxygen, carbon, nitrogen, etc. Well, if we can't see or detect 96% of the universe's components, then how can we even safely presume that they exist? Well, while we can't exactly see what scientists have named dark energy and dark matter, we can see how it affects the universe and its surrounding bodies. Let us start with dark matter, which is distinctly different from dark energy. Dark matter is known to comprise about 85% of the universe's total mass. And despite its apparent effects on objects that we can directly observe, the matter itself does not absorb, emit, or reflect light, which makes it significantly more difficult for scientists to analyze, since the tools they primarily work with electromagnetic radiation, which is essentially light. So where is the proof that it is indeed 85% of the universe's total matter? In 1933, a Swiss physicist named Zwicky, that's a tongue twister, was measuring and scaling a cluster of galaxies. When totaling the calculations he had drawn, he had noted that it was significantly more different than the output he was receiving. To illustrate, imagine you are going to weigh a total of 10 baseballs. You weigh one baseball and note it weighs 1 pound. Logically, since they are all identical, you can safely figure they collectively weigh 10 pounds. Okay, now imagine that after placing all 10 baseballs on the scale, you get 175 pounds. What? That arbitrary difference in weight is what is affiliated with dark matter. As humanity's understanding of the material continues to grow, it'll undoubtedly reveal further truths in our understanding of space phenomenons, such as the rotation of galaxies, celestial bodies, and motion clusters, and more importantly, venture with uncharted science that past generations never ever had the privilege to. Similar to dark matter, scientists have little to no idea what exactly is dark energy and what drives this powerful force. But they can view the drastic effects it has on our universe. Dark energy is what is believed to be expanding the universe at an incredibly fast pace. Whereas time continues, so does the ever expansion of our ever-growing universe. We can credit and analyze this theory because we can physically observe distant galaxies getting further and further away from our relative place in the universe. Essentially, dark energy is expanding the size of the universe faster than the speed of light. Eventually, the expansion will be so substantial that future generations will not have the capabilities of observing galaxies or objects in the distant universe. This is a direct consequence of the never-expanding expansion, and that is a direct consequence of dark energy. This is why it is crucial to continue the exploration behind the forces of dark energy. Likewise, since the energy itself has properties that show effects that have never been witnessed before, such as repulsive gravity and the ability to travel at the speed of light, which is forbidden by Einstein's theory of relativity, it is necessary to continue research in this sector of science. Additionally, a further understanding of this specific branch of science opens up a multitude of capabilities in theory. Which brings me to my next point: time travel. Time travel remains ambiguous and controversial in the realm of science. Einstein's theory suggests it is possible in a variety of situations. However, this raises speculations on whether it is only a mathematical fluke or whether it is actually feasible in reality. Time travel forward is straightforwardly possible. Backward, not as easy, but still theoretically possible. But let's go back to traveling forward in time. Traveling near light speeds allows for the plausibility of time travel into the future. This stems back to understanding what fuels and drives dark energy. Since dark energy can travel the speed of light under the manipulation and right circumstances, time travel is indeed possible. For instance, hypothetically, if an astronaut were to board a rocket ship traveling and accelerating at 9.8 meters per second squared, he would reach the center of our galaxy, the Milky Way, in about 20 years. His return home would be roughly about the same amount of time. However, upon his return, he would discover that in only 40 years of his time, he had traveled 40,000 years into the future. Other than figuring out how we could nourish, fuel, and maintain an astronaut and his rocket ship for the next 4 decades, this is relatively possible. Assuming, of course, we eventually understand dark energy to its fully potential, this in combination with future bright minds and some very complicated math is a recipe for development at an unprecedented level. As mentioned earlier, time travel backwards is significantly more complicated than the former. This is because time tends to only travel in one direction. It is important to note that Einstein's theory of relativity can be manipulated to bend time backwards, but unfortunately for every case that allows it, there are 100 reasons embedded in that very case that would not allow it and make it impossible, as if there is some fundamental rule that does not allow for the possibility of time travel backwards. However, as speculations continue to run high, this opens a whole new arena of questions, theories, and paradoxes, such as the one for immortality. Immortality, by definition, is the ability to live forever. And while the proposition seems absurd, it may very well be possible in the centuries to come. Life science has predicted that by the year 2045, technology will have surpassed human brain power. Some outlets even suggest that by the year 2100, technological and artificial intelligence will overtake humans. Let's hope it doesn't come to that. Similarly, they have also predicted that humanity will inevitably accomplish the feat of technological immortality. It just has to happen. It will happen since we are developing at an incredibly fast pace. Technology doubles in power and computation every 2 years. This is achieved by reaching a complex network of neural transmitters that resembles the brain and its intricate networks. The idea is to computize the consciousness, ideas, memories, and basically anything that makes up the personality of an individual and upload it onto a computer and a digital realm where they can live indefinitely. Needless to say that this is vastly easier said than done. In fact, researchers have determined that the ability to recreate the brain of a fly would take upwards of 3 years. And even when and if we are successfully able to upload the mind of an individual onto this complicated apparatus, there is still speculation and hypothesization on whether the entity present would truly be aware and conscious of its situation and circumstance. I mean, can you blame it? As technological advancements are achieved, advancements in the mentioned related branches of science will soon follow along with the revelations. Our frame of reference to the world of science has always been esteemed but never ideal. As humanity continues down the sterling path of science, slowly but surely will the universe's greatest enigmas begin to reveal themselves one by one, answering the many questions that remain unknown and converting a once fictional sector of science into the new reality of humans and their way of lives. Moreover, the fact that we are now able to envisage such elaborate propositions as within reach in contrast to outmoded ages that goes back as little as 120 years ago, including their objectives and intentions of and at the time, is cogent all of on its own. The accomplishment of such milestones will without a doubt change the course of human events. Ultimately, humanity is undeniably at a formidable position in science. Compared to prior centuries, the field of science has advanced so exorbitantly, future civilizations will be constrained to the fact that scientific breakthroughs will renovate and reshape how humanity functions and perceives their conceivable universe. As time continues to pass, abstract thoughts and theories continue to become more concrete and pragmatic, eventually leading to the preeminence of humanity and its mystifying creations. All of which are embedded in the mysteries of the universe. Thank you.